So today, okay, we have one more test to go and the final exam. And according to my paper, the final exam was initially scheduled for May the 10th.
No,
So now it's May the 17th. So final.
Is that our last class?
No, we have 4 weeks. We have 4 weeks plus the final exam.
Oh, I didn't
So we
know.
have
It's like a month later.
8
I had no idea.
meetings, including this one, plus the final.
That's weird.
Okay?
Doesn't that get like given away like summer classes or something?
No, there is a week in between. They chopped up that week.
Okay.
Okay, 4.9, antiderivatives.
That's interesting.
Antiderivatives.
Sounds like discouraged calculus.
No, not at all. So, what is an antiderivative?
Not pro, your coworkers.
What is an antiderivative? So, for example, let's suppose I am given f prime of x as 2x squared plus 3x plus 1. I am asked to find the function or functions whose derivative is that.
I thought that was what integrals were.
So, not yet. Not yet, but you're right. That's what I'm getting at. So, if I want to find or get x to the nth power, what should I differentiate to get x to the nth?
X to the third.
N plus 1 divided by n plus 1. So when I differentiate this, I bring down the power, which simplifies with n plus 1, and I subtract 1 from the power, and that's how I get x to the n. So now, based on that, I would like to find the function whose derivative is this. Oops. So based on just this formula. So f of x is 2. To get x squared, what should I do? X to the third over 3 plus 3 x squared over 2 plus x plus a constant c. I will simplify a little bit in the sense that I will write 2/3 x to the third plus 3/2 x squared plus x plus a constant c. Now, let's check. I would like to make sure that this, when I differentiate it, I get this function. I bring down 3, which simplifies, and subtract 1 from the power, and that's how I get 2x squared. I bring down 2, I simplify the 2, and I subtract 1 from the power, and that's how I get 3x. I differentiate x, and I get 1. I differentiate a constant, and I get 0. So basically, what am I saying to you is this, that this is a family of functions. How many? Depends on how many numbers I can put in there. This can be any real number. So
Each individual part of it is a family? What do you mean?
no, when c is 0, it's one function. When c is 1, is another function. When c is
Oh,
2, is
because of
another.
C.
Sigurd,
Okay.
sure. So because of c, which can be anything. So this is a family of functions. I have infinitely many functions whose derivative is this, right?
Right.
Now, this is also called the most general antiderivative of that.
You can get more specific?
This is the name, the most general. Yes, yes. Once we are given conditions, and I'm going to get to that in a minute. The most general. What is he saying? The most general antiderivative. Now I would like to go into some problems. On page 349, 348, 349, find the most general antiderivative of the following function. Before we continue, I just want to draw your attention to notation. There are two different situations. Notation. Given f prime, I will always find f of x. But if I'm given f of x and I'm asked to find its antiderivative, I will have to use this notation. And you will see later in chapter 5 why we make this distinction. If I'm given f prime, I will find a function that I have to call little f. If I'm given a function f and I'm told find the antiderivative, then the notation must be uppercase f. Okay? What's the big deal? You would say. Not a big deal. But it's a theorem that we are going to use, and that's why I need to make the distinction between the two. It's the same thing. Because I can rename this a function, right? And I can rename this another function, uppercase. Doesn't matter. But I would like you to pay attention to this because I don't want you to get confused. So if I'm given f prime like I was given here, I use the function notation lowercase f. But if this were called f, I would have determined uppercase f. Just to remind us of a theorem that we will discuss in chapter 5, okay? Good. So now let's look at problem 16 on page 348. And that's r of theta equals secant theta tangent theta minus 2e to theta. I'm given r of x, and it says find the most general antiderivative of this function. So I have to find a function that is r of theta. This is the antiderivative of r of theta, of lowercase r of theta. So I'm asking myself now, what function prime will give us secant tangent? Very good. Minus 2. What function prime will give us e to the... That's it. Plus a constant c. That makes it the most general antiderivative. When you differentiate this, I guarantee you get that. Okay. Okay, here is 22. F of x equals 2 plus x squared over 1 plus x squared. I don't have a formula for this. Till I get to integration, I don't know how to solve this. However, when I look at this function, I realize that the top can be rewritten. And look at the denominator, and you will figure out how to rewrite the top. How will I rewrite the top? But look at the denominator first. Exactly. And now I'm going to separate into two fractions. Can anyone tell me the fractions that I'm going to use?
1 over 1 plus x squared.
Indeed. Excellent. Because 1 plus x squared over 1 plus x squared will be 1. Very good. Now this is good. Now I can determine f of x, the antiderivative, the most general antiderivative of f of x. Which function prime is 1 over 1 plus x squared? Careful. Arc. If you remember, I asked arc sine x prime, arc cosine x prime, and arc tangent x prime. These are very important. Which one is it?
Arc is the same as the negative 1, right?
Yes, which is the inverse function. Yeah. No, this is 1 over the square root of 1 minus x squared. This is negative 1 over the square root of 1 minus x squared. And this is a very important function, 1 over 1 plus x squared. So it's arc tangent x plus
C. X.
plus x plus
C.
plus c. This is the most general antiderivative of the given function 2 plus x squared over 1 plus x squared. Okay, so now let's move away from that, and for example, I would like to look at 35, caught my eye, on page 349. And I have f prime of t is 2 cosine t plus secant squared t. They are telling us that f of pi over 3 is 4. And they are telling us that t is between negative pi over 2 and pi over 2, which means which quadrants?
I would say the right.
Exactly. Between negative pi over 2 and pi over 2. Good. Okay, so since I'm given f prime, the notation will be f of t. Which function prime is 2 cosine t? 2 sine t, excellent. And plus, which function prime is secant squared? Very good. Plus a constant. However, I am told that f of pi over 3 is 4. So f of pi over 3 is 4. So I have to plug in pi over 3. How much is sine pi over 3? It's not 1/2. 2, the square root of 3 over 2, plus tangent pi over 3. Okay? So I simplify. I have 2, the square root of 3 plus c equals 4. So how much is c?
It's root 3 over 2.
Yes, I simplified. So the square root of 3 plus the square root of 3 is 2, the square root of 3 plus the constant. So then now there is no family of functions, but there is one specific function. Can anyone give us f of t now that fulfills this condition as well as this condition? Can anyone dictate f of t?
2 sine t plus tangent t plus 4 minus 2 root 3.
So this is the unique function
1 root.
that fulfills the given conditions. Questions? 48. The third derivative is cosine x. F of 0 is 1. F prime of 0 is 2. And f double prime of 0 is 3. How do I start?
So
What do I have to find first?
f double prime.
Exactly. So let's find f double prime. What function prime is cosine x?
Sine x negative sine.
No, just sine x plus a constant c1. But I'm told that the second derivative at 0 is 3. So how much is sine 0?
0.
So c1 will be 3. So now I have that the second derivative is sine x plus 3. So this was done. This I used. So now what do I have to find next?
Negative cosine plus 3x
F prime.
plus C2.
So negative cosine x plus 3x plus c2. Excellent. I'm told that f prime of 0 is 2. How much is cosine 0?
That's
How much is 3 times 0? So how much is c2?
3.
So then I have now f prime. Can anyone dictate f prime?
Negative sine x.
Negative cosine x plus 3x plus 3.
Good. Good. Final step.
Negative sine x plus 3x.
So f negative sine x plus 3x squared over 2 plus
3x plus
3x plus c sub 0.
it doesn't matter how you denote it, but you can denote it by a, b, and c. It doesn't matter. So now we know that f of 0 is 1. Sine 0 is
0.
this when x is 0. This one x is 0.
Probably
So then C3 is
gotta be
1. So then the function is negative sine x plus 3/2 x squared plus 3x plus 1. And there is no other function that fulfills the given conditions but this one.
and this is an integral.
In a moment it will be, when we start chapter 5.
Don't block.
Okay, so I have a problem for you, which is 46, and then we move on.
Like she's saying.
The second derivative of t is 2e to t plus 3 sine t, and you are given that f of 0 is 0 and f of pi is 0. And I'm taking attendance because I will forget.
And so we're looking for chronic.
F.
It's not usually a letter I like having in notes in the classroom.
Do we have an answer?
Right.
Okay.
You don't have to be plug-in values.
Say it again.
You don't have any plug-in values for F.
That's okay.
That was a stupid. I put down X instead of T.
That's okay.
So, that's nice.
Okay. Ready?
I have to write down on.
Ready?
Go ahead.
Thank you. So we first find f prime, correct?
Yeah.
Okay. So I have 2e to t minus 3 cosine t plus c1. F of t is 2e to t minus 3 sine t plus c1t plus c2.
I did. Okay.
Right?
I was thinking C was X for some reason.
So I have f of 0 is 0. 0 in here, 2. 0 in here, 0 in here, plus c2 equals 0. How much is c2? Negative 2. So now, bless you. Now f of pi. 2 times e to pi minus. Actually, sine pi is 0. So I'm going to move on here. Plus c1 pi minus 2 is 0. So c1 pi equals 2 plus 2e to pi and divide by pi. c1 equals 2, if you want, in parentheses, 1 pi plus e to pi over pi. Can anyone give us now the function whose second derivative is given and some conditions are given? So 2 e to t
minus 3 sine t
plus this times t.
Yeah.
Wait, wouldn't it be negative 2e to the pi?
It's very possible. I'll check in a moment.
Minus 2.
Minus 2. Okay, yes. Here?
Yeah.
So when I plug in pi, sine is 0.
Yeah.
So this is 2e to pi, and this is c1 times pi, and this is minus 2.
How come?
Yes, of course it's minus.
Okay.
Yes, of course it's minus. Sorry about that. Thank you.
Now it's going to be easier to take the derivative of that and see that, oh yeah, that actually is quite sure.
Okay? Perfect. Any questions? Any questions? Very good. Do we understand the mechanism of finding antiderivatives?
Yeah.
Okay, very good. So now chapter 5.
That's structure.
Oh, that was the last section of chapter 4. Okay, chapter 5. F of x, I'm going to pick a very simple function, x squared. And I'm going to say on the interval 0 to 2. And the requirement is approximate the area under the graph, of course between the graph and the x-axis. So I'm going to say graph and x-axis on the given interval using n, lowercase n, 2, 4, 8, sub-intervals. So let's read the problem one more time. Approximate the area under the graph, of course between the graph and the x-axis, on the given interval using 2, 4, 8, 16, 32, 64, 128 sub-intervals. Okay? So, exactly. Okay, ready?
Yeah.
I'm going to graph this function between the interval between 0 and 2. I don't care for the rest. So when x is 1, y is 1. When x is 2, y is 4. So here's the graph. That's all we care about. So this is f of x equals x squared on the given interval 0 to 2. I'm going to start with n equals 2 subintervals. I'm going to divide this interval between 0 and 2 into two subintervals. And I have three options here. For each number of subintervals, I have three possibilities. Leftmost point is one option. Rightmost point is the second option. Midpoint is the third one. So, using the leftmost point of the interval, I will create in this case, two rectangles. The height is at the leftmost point. So then the first, let me try and find my blue or green or something. So the leftmost point, the height of the leftmost point is this. So the width of the interval is this, but the height is 0. So this is the area of the first subinterval using leftmost point. Now for the second subinterval, using the leftmost point, I get this. So, therefore, the area is approximately, I'm going to put A2 left. So area with two subintervals and leftmost point is the height of the first subinterval, 0, times the width of the first subinterval, which is 1, plus the height of the second subinterval, which is f of 1, multiplied by the width of this subinterval. So this is 0, f of 1 is 1, 1 times 1 is 1. So do you think that this area is underestimating or overestimating?
Under.
Of course. This is an underestimate. Very good. Now I want the area with 2, but with the rightmost point. So that will be approximately, I have to graph it again so everyone understands what I'm doing.
This is where you give all your practice balance.
I'll pay you to make him stop talking today. whatever you need.
Pick up on that.
Okay. Okay. So this is 0, 1, and 2. I'm kidding, of course. Okay. So using the rightmost point, this is the height, and this is the interval and the area. And using the rightmost point, this is the area. Therefore, height 1 multiplied by, or I should say the height is 1, and
F of 1
right.
versus 1. Height is F of 1.
Yes, I like to write it as f of 1. F of 1 times 1 plus f of 2 times 1. So f of 1 I know is 1 because it's x squared, right? And f of 2 will be 4. So the answer is 5. Is this according to your perception an underestimate or an overestimate? Okay. So let's look at A2 mid. So here's my graph again. Okay, and here's the midpoint. This is the height.
To be f of 0.5.
Yes.
That's significantly more accurate.
Always. That's true. Very good. So then this is approximately base, which is 1, times height, f of 0.5, plus base, which is 1, times height, f of 1.5. So 0.5, this is 1, so I'll take it out. So 0.5 squared is 0.25. 1.5 squared is 2.25. So the answer is 2.5. Which of these three you think, you already answered that question, but I don't know if everyone heard, which of these three will be a better approximation of the area under the graph between 0 and 2? The midpoint. The midpoint. Okay. Now, the next question or the next step is 4 subintervals. I'm not going to continue. I just need to talk about it though, because I'm sure you got the picture. So now I have 4 subintervals. If I use the rightmost point, I have this.
And so we're looking for the limit of the subintervals.
So do you think that this with the midpoint will be a better approximation than the area with 2?
Yeah,
Do you think that if we go to 8 subintervals, will we get a better approximation in all 3 cases?
see, we're going to infinity.
Well, more infinity self-approximation.
Okay. So how do I determine the area? So the area is approximately base times height, right?
Yeah.
What is the base, first of all? This is the base. Here's how we determine the base. If I am told n is the number of subintervals, how do I determine the width of the subinterval? What do you think we're going to...
Interval divided by the amount of
Exactly. Perfect. But how do we denote it? We had this notation several times before.
X to the n plus.
No. How do we call this?
I don't know.
Exactly.
Oh,
Exactly. Delta x. So this will be, if the interval is between a and b, this will be b minus a divided by n. So that will be the base. So now the height. In all these cases, what is the height? Where does the height come from?
F of
F of something, right? Excellent. So the height is F.
delta.
I'm going to call it xi.
Is that measuring number?
No. Very good. Very good. It has nothing to do with it. It's an index here. Very good question. Yes. So I is not the square root of -1 here. I is just an index. So please bear with me. Here is the interval between a and b. Here is the first subinterval. So this is delta x. And this is the next subinterval. So this is delta x. And next subinterval, and this is delta x. And somewhere in the middle, another delta x, another delta x.
Let me guess.
No, this is very important.
Delta
Please,
X.
please be patient.
I was going to say delta xi.
I'm getting to that. Exactly. Exactly, if you allow me. So this is also denoted a or also x0. What do you think I'm going to denote this by?
X1.
Exactly. What do you think I'm going to denote this one by? And this one?
X3.
Well, this is where it's xi comes into place. And where? What is this? X.
Plus 1.
Very good. And what is this?
Xi minus
And this is n minus 1. What will this be?
X.
Indeed.
There we go.
So now it doesn't matter if you denote by xi the leftmost point, the rightmost point, or the midpoint anymore. Why? Because eventually n, as you already figured out, will go to infinity So it doesn't matter. They are so close to each other that it doesn't matter if I use the leftmost point, the rightmost point of the interval, or the midpoint. So now let's write again. So the area is approximately b minus a over n, that's the base, times f of xi. However, I have to put something else in here, right? The word sum. So the area is approximately the sum of these areas between b minus a over n, which will always be the width of the interval, times some f of xi.
Isn't that like the large epsilon?
Right, that's what I'm getting at right now. So this mathematically is denoted by the Greek letter S. So this is an S, but it's a Greek X. Okay? And it goes from, it has to have a lower limit and it has to have an upper limit. The notation, I'll explain how we use this. From I equals 1, from the first subinterval, second, third, yada, 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 till the last one, till n. So how many subintervals I have here? 1, 2, 3, I plus 1, I plus 2, n minus 1, n.
Why isn't it I equals 0?
Because I don't have an interval 0. I have the first interval, which is x between 0, x0 and x1. So that's the first subinterval. It's not the interval.
Like
It's not the interval 0.
the right point.
It's not the interval 0. You're talking about this point
Yeah.
as being x0, but I'm talking about the first interval. So from I being 1,
It's the difference between.
from I being 1 for the first subinterval till I being n, where I have the last subinterval. Okay? So now let's make some adjustments to our notation. So then the area is approximately the sum from I equals 1 through n from this product of base times height. Okay? Now, is there a way that will change the approximation symbol into the equal symbol?
Yeah. N is equal to infinity.
So question is, what am I missing here? That makes this approximation symbol change into the absolute exact equal.
Limit as n approaches infinity.
Absolutely. That's all I'm missing. Exactly. The limit as n approaches infinity. Now there is no missing portion. This has a special name. It's called Riemann Sum. Mathematician called Riemann. He came up with it, so it bears his name. So I will write that A equals the sum of the, I'm sorry, not the sum, the limit of the Riemann sum. I think his name is spelled with double N, not with double N. Yes, so sorry. I'm wrong. So I just realized. Okay. So it's double N at the end, sorry. Okay, so now let's play a little bit with this because I need to show you how to, what it means and so on and so forth, and how we approximate, how we use it. And then we can use different functions to determine this exactly. It's not an easy process, so please pay attention. So, for example, if I have the sum of 1 from I equals 1 through n, what does this mean? When I is 1, I have 1. The sum tells us to add. When I is 2, 1 plus. When I is 3, 1 plus.
So it's
And so on and so forth till the last one, which is 1, but I have n of those. So what would be this equal to for sure?
n.
Very good. Because the sum from I equals 1 through 4 of 1 will be 1 plus 1 plus 1 plus 1, which is 4. We are going to use this result, so please remember it. The sum from I equals 1 through n of 1 is n. Okay, now 8. So the sum from I equals 1 through n from I. What does this mean? So this is just a way of condensing all this. So I'm condensing it into this notation because I don't really like to write this, but this is easier to write. But this is what it means. So what will this represent? From I equals 1 through n, when I is 1, 1 plus, exactly. Plus? Good. In pre-calculus, we showed that this equals n plus 1 divided by 2. Like the previous one, you must remember it. This is a very important result. Remember this. So now remember this. Okay, what about the sum from I equals 1 through n from I squared? What will that look like?
1 plus 4 plus 9.
1 squared plus 2 squared plus dot 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 plus
N squared.
n squared, and this is n plus 1, 2n plus 1 divided by 6. And yes, we have to remember this one as well. And there is one more, last one. Sum of I to the third from I equals 1 through n. What will this equal to?
Like 1 to the third plus 2 to the third plus 3 to the third dot 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 n to the third.
Easy to remember. It's the same thing but squared.
N plus 1. Oh.
Okay?
Threw your curveball.
It's easier than the other.
Yes, it is. This is the most complicated one. So now, for example, let's suppose I have something like this. The sum of 3i squared plus 4i from I equals 1 through n. This can be separated like the limit. How would you write it? Imagine that it's a limit in there. How would you write it as separated?
Sum 3i squared plus
3, the sum from I equals 1 through n of I squared plus 4.
sum I.
Very similar to the limit. Any questions? Any questions? So now I'm coming back to our function x squared on the interval 0, 2. And now I'm not going to say approximate using 2, 4, 8 subintervals. I'm going to say find the exact area under f of x. Of course, it is to be understood between f of x and the x-axis on 0, 2 using the limit of the Riemann sum. Ready? We need 4 preps. 4 preps. 1. First prep, delta x. Can anyone give us delta x?
B minus A over n.
Exactly. 2 minus 0 over n.
To 2 over n.
Excellent. Second prep, xi. So let's come back here for a moment. And write x1 first of all. x1 is x0 plus 1 delta x. What about x2?
X0 plus 2
2 times delta x.
Or x1.
What about xi?
X0 plus I delta x.
Excellent.
I delta x.
Exactly.
Maybe U delta x.
So delta x, I meant to write 0 in this case.
Out comes the white out.
That's 0 because f of 0 is 0 or because x is 0?
Because x is 0. Right? x0 in our case is 0. It would be more difficult if it weren't 0, and I will work on a problem with when it's not 0. So this in this case is 0 plus I delta x. So 0 plus I delta x, which is 2I over n. We agree or not? This is 2 over n, and this is I, so it's 2I over n.
Oh, you should plug delta x.
Oh. Okay.
3,
I said, oh, so
f of xi. I have x squared, so I have 2I over n squared, which is 4I squared over n squared. Agreed?
yeah.
And in number 4, the area equals the limit as n approaches infinity from the sum from I equals 1 through n of base times height. Base height.
8I squared over n to the third.
Any questions so far? Okay, let's continue. So this is limit as n approaches infinity. This is a constant. This is what we did with a constant. We took it outside. So this is 8 over n to the third, the sum of I squared from I equals 1 through n.
And we know I squared.
We do know this. Anyone remembers?
Just slightly. I believe it's n, well, n plus 1, 2n plus 1 all over 6.
Very good.
Poor Ben.
Ready?
Sad, yeah.
I can't do anything if there's a comment after each and everything I say or do.
Yeah, there is.
Okay. Ready? So this with this, this with this, so limit. So n approaches infinity. 4/3.
N plus 1.
So I multiply these two, 2n squared plus 3n plus 1. And the denominator has n squared. Because I took 4, okay. We know what this limit equals to when n approaches infinity even from pre-calculus with no
1,
no
2.
leading coefficient over the leading coefficient. So it's 2 times 4 over 3, 8 over 3. There is no approximation here. This is the area under the graph of x squared between 0 and 2. No approximation whatsoever. Now, however, with this method, with the limit of the Riemann sum, we are limited only to polynomial functions. So limit of the Riemann sum works only because we are limited, not because it will not work actually. It will work, but we don't have tools. So I'll say works just for us, just what we can do, works only for polyfunctions. Only degree 1 through 3. That's it. Yes,
Tangent, but
we can't. we don't have a formula for tangent.
No, I was thinking like
Oh,
in my head, I was
oh, okay.
running
Sorry.
just a little. What day of the week is the final?
That's what you've been thinking?
No, I just had my.
May the
No,
17th.
like just like in the past, like.
May the 17th. I don't know. I have to look. What day is that?
Okay. It's a Tuesday.
Yeah, I can
Okay.
check 1 second. I put it
Yes, it is a Tuesday.
Yeah, it's Tuesday.
Okay.
Okay.
It's just gonna bother me if I didn't ask.
Okay. Good.
Better when Anthony-
So the limit of the Riemann sum works only if we use polynomial functions degree 1 through 3. For everything else, we have a different method. But for now, let's choose another polynomial function. Please give me a polynomial function.
X to the.
No,
X to the
degree
first
1
power.
to 3.
Oh.
Sorry. X to the first power.
Okay, negative 2x cubed plus x minus 3. And give me an interval. Now, if you want an interval that does not start at 0, I recommend we change the function to make it a little bit more human. So, 1, 2, perfect. This will be slightly more difficult because the starting point is not 0. So, step 1. Step 1. What do I need in step 1, please?
We need delta x, yeah.
What is delta x? Very good. Number 2, xi, please.
I don't know.
The starting point, which is 1 plus I times delta x. So this is 1 plus 9I over n. Step 3. What do I have to find in step 3?
F of
X.
And that's a mess. So, negative 2 in parentheses, 1 plus 9I over n squared plus 1 plus 9I over n minus 3. I have to simplify this fully before I put it in the limit of the Riemann sum. Ready? What will you tell me to do first to simplify this function?
We'll distribute.
I cannot. I have to square first, right? A binomial. When I square a binomial, what do I get? So 1 plus 2 times the first times the second plus the second term squared plus 9I over n minus 2. Now I will distribute. Negative 2 minus 36I over n minus 162I squared over n squared plus 9I over n minus 2. In descending order now.
162.
Negative 162I squared over n squared minus 27I over n
Minus 4.
minus 4. Now I'm ready for step 4. The area is the limit as n approaches infinity from the sum from I equals 1 through n from base 1 plus 9I over n times the height. What was the 9 over n? I'm sorry. I'm going to do this. So limit as n approaches infinity, I equals 1 through n. 9 over n, that's the base, times the height, which is all this.
That's
Neg-
delta x.
Yeah, that's the height.
Base times.
The height is always I'm sorry.
It's base.
The base is always delta x. Okay. Over n squared I squared minus 27I over n minus 4. Good.
Don't be critical of delta x. I call it base.
9 over n does not depend on I, so it goes in front. So limit as n approaches infinity, 9 over n, the sum of the first term with minus outside, 162 over n squared I squared minus, I should have taken this already out, but that's okay,
Minus 27.
I over n, I equals 1 through n, and minus the sum of 4 I equals 1 through n. So now the next step, I will take this in front, I will take this in front, and I will take this in front. And I will factor out negative and put it outside. 9 over n, 162 over n squared times the sum of I squared, plus 27 over n, the sum of I, and then plus 4, the sum of 1. So, negative limit as n approaches infinity, 9 over n, 162 over n squared. Now I have to replace this. What do I replace it by?
N times n plus 1 times 2n plus 1 all over 6.
Excellent. Plus, I have 27 over n. Now I have to replace this.
N plus 1 over 2.
Plus 4. And now I have to replace this. Excellent. So what did I accomplish so far? I'm far from the end, but I accomplished this. First of all, I have base times height. I got rid of the first or second step. I got rid of all the summation notations, and I replaced them with what they equal to. And now I have to do the algebra.
Summation notation.
Okay, so let's try and simplify this a little bit. 2n will not go away. 162, that's 6, 7, 8, that's 9, so by 3. I want to keep 2. I want to keep 2n because I cannot simplify here. So 6, I'll simplify by 3. And this by 3. 54, isn't it? 6 divided by 3 is 2, and this is divided by 3 is 5 and 12. Okay, so I'll simplify 1n. So I have 54, and I will distribute this. Or for now, let's write it. So 2n squared plus 3n plus 1 plus, I will not simplify 1 to 2n, 27n squared plus n. And this needs to be multiplied by 2n, and I get an 8n squared. So far, so good?
Haven't killed over yet.
Okay, 9 over n. And I can multiply these two in a moment. So I have 54 times 2.
8.
Yes. N squared plus, I don't care about this term, I don't care about the next term, plus 27n squared. I don't care about, yes,
Okay.
absolutely not.
An expression of n.
The reason why I don't care about these, let's
They're
put,
lower
let's put,
values.
because the denominator will be 2n squared, and all I care about are the squared terms. But let's put them in. So, so this is 162n. And then that's 54, and this would have been 27n.
Were you joking when you said absolutely not?
Yeah, I want you to write all of them because it may be confusing. But I'm really interested in these.
I got mine.
Of course she was joking.
So finally, negative limit as n approaches infinity. The denominator is 2n squared. The numerator is 108 and 27 and 8.
Wait, how did that 27?
27 times n squared.
I thought it was supposed to be negative at first because of the way the circle. It's not negative.
No, it's not negative. No. So what do I get? 16. Excellent. And multiply by this 9. And then the rest,
Which we don't care about.
which we do care about. So the simplified form is 143 times 9 divided by 2. So because the limit will be the leading coefficient over the leading coefficient.
What's a negative?
Oh, it is a negative because
Oh.
we didn't graph the function. So if the area is this, then the area is positive. But if we graph that function and the graph looks like this, between we chose 1, okay, between, let's say, between 0 and 10, then the area will be negative.
So the negative
It
was
only
there
means-
because you knew it was there.
It only means that the graph is underneath, or it can be this, right? This is positive and this is negative, and it could be that this area is bigger than this, and that's why the result is negative.
Okay.
So how much do we get here? 6 what?
640.
Oh, you divided already.
Yes.
I would have kept it. Okay, that's fine.
Well, 87/2.
That's fine. So 643.5.
643.5.
Okay. Perfect. So now it's your turn to perform all these calculations. And I'm going to choose a function.
Calculus is a performing test.
Yes, it is. So let's say f of x equals 4x squared minus 2x plus 1. The interval is nice, 0, 3. And I need the area under the graph.
Okay.
I made it nice for many reasons. Number one, because
Zero.
it says 0. Yeah.
Wait, you made it nice because it starts with 0?
Yes.
Or it starts with 0
Because it will be easier to plug it in. You're not going to have a binomial to plug in.
So instead of it being 0, instead of you making it nice because it's 0, it is 0 because you made it nice.
Yes.
She's drinking water right now. She'll be glad.
Grab it, break it. Yeah.
Please read the book. You may find that the method in the book is easier for you. I don't know. It doesn't matter to me.
Okay, so first you find delta x.
Yes.
Then what?
Which is going to be 3 over. And you find x.
I would like to draw your attention here for a second. So you can see that some areas are positive, some areas are negative.
Right.
And it depends which one is bigger, the area could be considered or end up being negative, depending on which of these two portions is. So it's possible. Good. Do we need more time? Just kidding.
Just kidding. You don't get any more time.
Is this right so far?
Yes.
Thank you.
Just simplify it before you put it in the limit of the Riemann sum. You're making your life more easy, easier.
Yeah.
Why would we want to make life easier? Professor Lee, okay, we can hear that, please.
Oh, yeah. Of course. Your book calls that xi star. It's not important. It doesn't mean anything.
Okay.
It's xi, that's good enough.
Do we write the limit as n approaches infinity or the limit as I approaches infinity?
No. The I is not for the limit. The I is only for the sum.
Okay, so we write n.
Yes.
Okay.
Yes. So you have n subintervals, and they go from the first subinterval to the nth subinterval, but you need a generic one that goes from 1 to n. Yep. Okay, ready? Can we start? Ready? Yes? Okay. So number one, I have to find delta x, 3 minus 0 over n. Number two, I have to find xi, which will be 0 plus I delta x. 0 because it's this is 0. So this is I times 3 over n, or 3I over n. Then in step 3, I have to find f of xi, which is 4 times 9i squared over n squared minus 6i over n plus 1. And after simplifications, I have 36i squared over n squared minus 6i over n and plus 1. I'm now ready to write a is indeed equal, exact, no approximation, limit as the number of subintervals goes to infinity, and the sum of the areas of all subintervals. So I have delta x, which is 3 over n, times the function, which is the height of each subinterval, from I equals 1 through the last one. So this is 36i squared over n squared minus 6i over n plus 1. Yes?
Is there a difference, it doesn't matter, whether the summation goes first or the limit goes first?
It's mandatory the limit to be first, because the definition is the limit of the Riemann sum.
Right.
Better?
Yeah.
So this is the Riemann sum, and the area is the limit of the Riemann sum. Remember, we determined this, and then I asked you, I'm missing something to make this exact. So that's why I needed the limit operator. Better? Perfect. Okay, so then the area is limit Sn approaches infinity. So I'm going to take this outside, and what do I get? Is it 108 over n cubed?
How do you know that you can do that?
Very good. Because of what we discussed. Very good question. If I'm asked to find the sum of these two, 3 goes outside, and I only have the sum of I squared because it's a factor. So what will I have here? I will have 3 times 1 squared plus 3 times 2 squared plus 3 times 2 to the times 3 squared plus dot dot dot. So then I'm writing 3 the sum of I squared.
Does that mean for the one we're on right now, we could take out the 6 over n or no?
6, you have 3 over, yes, I didn't get to that far. Hold on 1 second. So I have 3 over n times this, and I get 108 over n cubed, and then I have the sum of I squared.
Oh.
Then I have negative 6 over n times 3 over n, so this is negative 18 over n squared, the sum of I. And then plus 3 over n, the sum of 1. Or you can just put this in front and wait to separate the other 3, so I don't confuse you. Is that better? So you can put 3 over n outside and then the sum of this, and you will have 36 over n squared, the sum of I. And then you will have negative 6 over n, the sum of I. And then 3 over n. Yeah, I did 2 things in one. Am I confusing you, or should I redo this step?
Is that where you can just show both steps?
Yes, I can do it in 2 steps. You want me to do it in 2 steps?
This is probably confusing.
Okay, so let me write this one more time. So then, so the area is the limit as n approaches infinity from 3 over n and the sum of 36i squared over n squared minus 6i over n plus 1 from I equals 1 through n. So the only thing I did was I took this outside, and then I have the sum of this minus this plus this. Is this okay? Are we okay so far? Would you agree? You disagree? Is this okay? Okay, so then this is limit n approaches infinity 3 over n. And now when I'm not distributing the summation notation, but the sum of a term plus a term plus a term is the sum of the first plus the sum of the second plus the sum of the third. So I'll say 36 over n squared, the sum of I squared, minus 6 over n, the sum of I, and plus the sum of 1. Is this okay? So this of this with a factor in front, this here with a factor in front, and this here with, I don't have anything else. Okay, so then I need to replace this, I need to replace this, and I need to replace this. What does this equal to? This and this, that's it. So then we have limit as n approaches infinity 3 over n. So 36 over n squared multiplied by n plus 1 to n plus 1 over 6 minus, bless you. Do you want me to adjust the heat? You're sure?
Yeah.
Plus n. Yes, I will definitely do it because I can simplify it here as well. And I'll simplify here as well.
So you can't simplify all the way.
Yeah, don't bother. Yeah, because then you have to multiply. So limit as n approaches infinity 3 over n. The denominator will be just n. So I have 6 and then 2n squared plus 3n plus 1. Then I have minus 3n squared minus 3n and plus n squared. Don't forget to multiply by n. So finally we have limit as n approaches infinity. The denominator is n squared. So this will be 12. 12n squared plus 18n plus 6 minus 2n squared minus 3n. So limit as n approaches infinity. So I have 3 and I have 10n squared plus 15n plus 6. Yes.
Why did the 3n squared turn into a 2n?
Because I had this and this.
Oh, okay.
So the answer is 30. Questions? Questions?
Yeah, we did it.
Let's check. We determined a couple of Riemann sums, limits of the Riemann sums, and I said to you this is the exact area. Here's the second method that I'm sure you will enjoy much better than this one.
Is it? This is something we did. completely different? It's not Riemann's anymore. You're gonna show us something different.
Yes.
It's good to have variety.
This is limited. The limit of the Riemann sum is limited when we want to find it exact, the area. But it's very helpful, and I would like to talk about the midpoint rule in a minute. But I want to, since we looked at a couple of limits of the Riemann sum, I would like to show you that these are exact. Okay? So here's the second method. So we know now that the area is the limit as n approaches infinity, number of subintervals approaches infinity, from the sum of all the areas from 1 through n, delta x, f of xi. And this is the same thing with what it's called definite integral. And here's the notation. It's the same thing, but this time is the Latin S. And it doesn't look like this, but it looks like this. Between A and B, it's the same thing. F of x, but instead of delta x, we will write, what is the other one? That is always exactly. So this is f of x dx. So the area can be calculated with the limit of the Riemann sum, or it can be calculated with a definite integral. But now how do I calculate this? And then we'll go back to each and every problem we solved tonight to check with this. To check that this, what we got with the limit of the Riemann sum, is the same with what we get with a definite integral. Ready? First of all, how do I solve this? So this is the Fundamental Theorem. Exactly. Super important. It has two parts. I'm only going to talk about this one right now. The integral from a to b from f of x dx is calculated, and please tell me what does this mean. That's why I made a big difference. I made a big fuss out of the notation. What is this, f of x?
It's the integral of
The antiderivative of f of x. And evaluated from a to b, which is the same with, I plug in the upper limit and I subtract when I plug in the lower limit. So I would like to go back now to the last one. And the last one was, we had a function 4x squared minus 2x plus 1, and the interval was 0, 3. So please dictate what I should write in order to determine the definite integral for this function. The integral from 0 to 3, excellent, from 4x squared minus 2x plus 1 dx. Mind you that dx is the base. The function is the height. Instead of this, I have this. It's the same thing. But now, since we covered the last section of chapter 4, I know what is the function whose derivative is 4x squared.
4, so the third of it.
Excellent. Minus 2. I know which function prime is x. Plus, I know which function prime is good.
Plus C.
No, not anymore, because I will have to subtract them and it will go away. From 0 to 3. So then, according to this, I will plug in 3 in this function, and I subtract when I plug in 0. Ready?
Are you ready?
Yes, I am ready. So 4/3 times 27 minus 9 plus 3 Should I plug in 0 in these three terms? I will get 0. Okay, good. So I'll simplify. 4 times 9 is 36. Minus 6 is?
So, yeah.
But that makes a lot more sense to me.
Thank you. Of course.
I wish they teach us the fast and useful methods.
No, they are both useful, and I'll show you why. I'll show you in a minute why they're so useful, both. So now I want to go back to the previous one. I don't remember. What was the previous one?
Integrals are useful for integrals.
So the previous one was f of x equals negative 2x squared plus x minus 3 on 110. I'm waiting for your answer. 2 minutes.
2 minutes. We lost 3 minutes somewhere.
We want to use the limit, not the limit of the Riemann sum, but the definite integral, please. We are calculating this definite integral between what and what?
Between
1 and 10. Excellent.
And then inside is it f of x times dx?
Exactly the same thing. Base times height, but written as height times base. The exact same thing.
Question.
Yes.
What's the deal with dx?
What is what?
What's the deal with dx?
It's the same with delta x, the base.
Okay.
It's still the sum of areas. Base times height. Base is dx, height is f of x.
So what do I do with that?
The integral doesn't make any sense without a dx.
Yes.
It's the area. You're adding areas of rectangles.
I know what I'm doing. I've gotten to the point where the integral on that, but dx just sitting there.
Like what do you plug
No,
in?
dx goes away once you determine the integral, the antiderivative.
Okay.
Okay, okay. So we just have to write it.
Yes.
Ah,
Right.
yeah. Okay. Now would it just turn into x, or would it go away?
Dx will go away, like here, like in the limit of the Riemann sum. It's this. This is dx, right? So it will be eventually get incorporated, so you don't have to do anything.
Can we go back to the
So right here. So this is the integral symbol. This.
Can you go to the one we just did?
Yes.
Okay. Alright, yeah, so just I think
Oh, it's the f of b minus f of a.
Yes. We have an answer? Is it the same with the one we got before? It better be.
Or
It better be. Otherwise, it's a big problem. I don't remember what we got.
so how can we figure out if it's the same as that?
Okay, can anyone tell me what to write?
Negative 2x cubed divided by 3.
Plus,
X squared divided by 2.
minus.
X.
From 1 to 10. I have to plug in 10 first. Negative 2/3 times 1,000. plus 100 divided by 2, which is 50, minus 30, minus, in parentheses, careful when I plug in 1, negative 2/3 plus 1/2 minus 3. So, negative 2,000 over 3 plus 20 plus 2/3 minus 1/2 and plus 3. Negative 2,000 plus 2 is negative 1998 over 3 plus 23 and minus 1/2. What is the least common denominator?
6.
So this needs a 2, this needs a 6, and this needs a 3. Okay, I'm lazy. I'm going to use a calculator now. So negative 2 times 1998 plus 6 times 23 and minus 3. 3861. And I divide this by 6. Ah, yes. I remember this ugly number.
Oh.
Is that a line you use a lot?
This one?
Is that a line you use a lot? Ah, yeah.
Oh,
I remember this idea now.
Oh, I'm sorry. Okay, I'll take care of that. Okay, so now I want to show you how important the limit of the Riemann sum is. Okay? So, let's look at a problem. Allow me to pick something
Is the Riemann sum useful
very useful.
without the limit?
No,
You keep
because
saying the limit of the Riemann
If you
sum.
don't
right,
want
because if you don't use the limit, it's an approximation.
Yes.
You don't want it accurate, you just want to find it.
Exactly. Exactly.
Without a derivative.
I want to look at a function whose antiderivative we cannot find, like the integral, let's say, from 1 to 2, from e to x squared dx. We cannot find this antiderivative. It's not going to work. So we want to find this area, and we will be using the midpoint rule. So let's talk about the midpoint rule. Yes. So the integral from a to b from f of x dx is approximately, and here's the midpoint rule. As we know, the sum from I equals 1 through n, definitely from delta x, as we know, times f of xi. But this time, of course, delta x is the same, b minus a over n. But this time, xi is the sum of the left and the right. I mean, it doesn't matter which direction you're going. So xi minus 1 plus xi divided by 2. And this time, I have to call this star. Because it will be confusing with xi minus 1 and xi. So now xi star has a meaning. In the previous situation, there is no need to put a star in there. But now this is important because I am told if this is xi minus 1 and this is xi, the midpoint here is xi star, which is the sum of these two divided by 2. So I would like to approximate this. And we have to decide upon how many subintervals you want to use. Okay? Let's use 3. So the area will be approximately delta x will be 2 minus 1 divided by 3, so 1 divided by 3. And now, since I have 3 subintervals between 1 and 2, this is 1, so this is 1/3 plus 1/3 plus 1/3, right? This is 1 and 1/3, and this is 1 and 2/3. So I have 3 subintervals. I have to use the midpoint. So I have f of this plus this divided by 2. 1 plus 1 and 1/3 divided by 2 plus f this plus this divided by 2. 1 and 1/3 plus 1 and 2/3 divided by 2. And plus f of 1 and 2/3 plus 2 divided by 2. Yes, I'm going to use a calculator and punch in this.
Yeah.
So the function is e to x squared. So e, and in parentheses x squared. And then second and table. So I will plug in parentheses for the top, 1 plus 1 and 1/3 is 4/3. Close the parenthesis and divide by 2 and enter. Then the next one in parentheses, yes, 4 divided by 3 plus 5 divided by 3. Close the parenthesis and divide by 2, enter. And the last one, 5 divided by 3 plus 2, parentheses, 5 divided by 3 plus 2, close the parenthesis and divide by 2. Okay, so now here are the values. 1/3 in front and in parentheses, 3.9005 plus 9.4877 and plus 28.821. So now I add those and divide by 3.
It's the hard part.
So 3.9, what is it? 9.0. 3.9005 plus 9.4877 and then plus 28.821. Okay, 42.21 roughly. And this is tremendous because I can never find an antiderivative of this. Can you say this is a good approximation? No.
Did you multiply by 1/3?
Yes.
Really?
Mm-hmm. I divided by 3. Oh, no, I thought I put it in front. Sorry. 14. Okay, sorry. So this divided by 3. Thank you so much. So 14.07. Thank you. So
Now that's a reasonable.
is this a good approximation? Yeah, right. Is this a good approximation? No, because I'm using 3 subintervals, but it gives me an idea. So it's really a good. Yes. Yes. Any questions? Okay, let me tell you what we accomplished today. We accomplished 4.9. We accomplished 5.1. And we almost finished 5.2. I did not present the properties of the definite integral yet. So I'm somewhere in the middle of 5.2. What is left? 5.3, which we already touched upon because I presented one part
What is it?
of the Fundamental Theorem of Calculus, part 1. I have to talk about part 2. And then 5.4, we're going back to the integrals, but this time the indefinite integrals. And then the last section is the substitution rule.
So that's the rest of the semester.
That's the end of the semester, yes.
Okay.
So I'm anticipating or having an idea like this. So we do have 7 more meetings
8 plus the final.
plus the final, yes. But okay.
That means
So this week I will review what I did today and make some more steps forward. And then next week I'm hoping to be able to finish the material. So the following week we're going to have, on Thursday, we're going to have test 4.
What's the date for that?
That's what I'm going to look right now. So I'm hoping to
So not this
finish.
next Thursday, but
I'm hoping to finish this